Yeah, when I left off last week, I asked you kind of to think about this over the week. Maybe you remembered, maybe you didn't. But if you did, who thinks they have a way to model a sphere in Onshape, a ball? Anyone? If you didn't think about it, you can think fast and make some suggestions. I do want to hear a couple answers before I move on. Take a guess, perhaps. What kind of sketch would you make?
Maybe just like a bunch of circles.
Okay. Yeah, so a bunch of circles. Maybe you're thinking like an extrusion. You have a smaller circle, you extrude that up, and so on. Yeah, so that is one way to do it. And as you suggest that idea, I'm sure what you realize is, and I'm sure what most people realize is, just using the extrude feature, it's not very easy to create the sphere, just because you end up with these walls that are vertical. So what you end up with is this cylindrical surface rather than a spherical one that also kind of curves inward as you go up. So I think the idea that I heard was perhaps we can make a circle, go up, create a smaller circle, and go up. And I don't know like average age or school grade you guys are in, but if you guys have taken calculus, this is kind of the limiting approach to making a sphere. So like in theory, this will work. You just have to make them thinner and thinner, make the diameter gradually decrease, and that'll make the sphere. Last call for ideas before I pull back the curtain and spoil everything. Any guess is fine. So I'll show you the answer now. And this is just using the tools that we've talked about so far. So nothing new. In theory, you could have done this yourself last week, right? I have my fillet tool. And as long as I match my dimensions, I end up with a sphere, perfect ball. It's the same all the way around. So great, I've done it. Why was I making such a big deal out of this? The thing is, let's say that I'm designing this for a project or a job, and I make this one day. The next day, I find out that I have to make a sphere that's not 1 inch in diameter, but 2 inches in diameter. So I go back into my sketch, and what do? Check the dimension, 1 inch. I really want it to be 2 inches, right? But I do that, and the fillets haven't updated. This isn't a sphere anymore. So what do I have to change? I have to change the extrude height. This has to be 2 inches. And it's still not a sphere. I have to change the fillet radius too. Make this 1 inch. And so just to do one simple task, which was changing the diameter of the sphere, I had to change 3 separate things and 3 separate things in my feature tree. And I had to remember which one to do. It's a lot of work. And you might see that that's perhaps not the best way to make a sphere if you're going to be doing a lot of changes to your part. So what's the alternative? I kind of teased this last week. I'm going to use our next feature right, so far we've talked about the extrude feature, the fillet, and the chamfer, if I remember correctly. I think we also talked about the patterns. And so that's what you've got so far to work with. Now we're going to add revolve to that list. So I'll do a quick demonstration. And I'd say do follow along with this one just because it'll be your first time using it. And the objective here, I'm going to make a sphere. So like I did before, I'm still going to start with a sketch that's a circle, say 1 inch. And what I'm going to do differently is I'm going to create a bit of construction geometry. So I got my circle and I'm going to create a diameter of it. And I know I've mentioned this before. The way I did that, when you hover over a certain part, Onshape can sometimes try to guess what you're trying to do. In my case, I'm trying to make a diameter, which means it's a line that goes through the center of the circle. And I'm making one that's vertical, right? So a circle only has one vertical diameter. So if I hover my mouse kind of vertically over the center, the origin, and you'll see these constraints, these two white boxes, those will come up. And when I click, I line my cursor up again for the other end, and I click, and you'll see it turns black because, like I said, there's only one vertical diameter that this circle can have. The circle is fully constrained and dimensioned, so everything is still fine. And that's all I'm going to do. That's my entire sketch. Let me know if you had any trouble getting to this point. I imagine it's fairly straightforward. All right. And now for the reveal. You click revolve just like you click extrude or any other feature. The window comes up and it asks you for a face and or sketch region to revolve. That's pretty much exactly the same thing the extrude window asks you for. Extrude also asks you for a face or sketch region to extrude. So it's the same thing. And what I'm going to click is this part of the circle. So kind of that semicircle, half a disk of area. And you can see nothing happens. I don't see any previews, and that's because the revolve takes 2 parameters. Extrude only took 1. All I had to do was select I guess technically 2, but for an extrude, once I selected a region, it knew what I wanted to do. There's only one thing it can do, which is create the extrusion. But for the revolve, you need to specify another thing, which is the revolve axis. And so before I really explain what these are, I'll just show you what it does. I picked that line that I drew as my revolve axis. And you can see what happens is it creates a sphere right away. So maybe you understand what's happening. It's essentially taking this semicircular region, this profile, and it sweeps it around. It revolves around that line, this vertical axis. And as it goes all the way around in a full circle, that's what this word full means, it keeps all of that volume that's swept through. And of course, when you sweep a semicircle about its diameter, then what you end up with is a sphere. So that's kind of how that worked. Hopefully you're also able to do that successfully. If you weren't able to make this, please ask a question, and I'll wait a second before I continue. Can't click the line. So your sketch looks something like this, right? And you can see the line and the circle, I imagine. Yeah, okay. So for the region, does it allow you to just select one of the semicircles instead of the whole circle? And you can see the orange outline kind of goes like that. Okay. Then you click the revolve axis. That's telling Onshape that the next thing that you select is going to be for this parameter, the parameter which is your revolve axis. And does it allow you to click the line that you drew? Okay, great. So I'll guess that everyone's pretty good with that now. So I'll mix things up now. What would happen if, let's say, I drew a line like this and I had a circle out here. And I know I didn't dimension anything or constrain anything, but I can make it look a bit clearer just by I'll move the circle up a bit. So my sketch looks like this. And let's say I do a revolve where I use this as my profile. So this is what's kind of getting swept around. And let's say that I'm going to select this vertical line as my revolve axis. So kind of imagine in your head what would happen if I took this circle and I kind of swept it around this line in three-dimensional space. What kind of volume would that enclose? What kind of shape will it produce? I'd like to hear some guesses, some predictions, some answers. Maybe if you're.
Wait, could you say the question again?
So what kind of space, what kind of shape would I produce if I selected this vertical line as my axis right now? If I swept this circle around an axis in three-dimensional space, what kind of volume do I enclose? What's that shape? Maybe similar to some objects that you've seen in your day-to-day life.
A
Any
donut.
guesses? A donut. Excellent guess. To reveal it, yes, that is what happens. You can see this circle is kind of being traced around the vertical axis. And so what ends up happening is you do get this shape, also called, I guess, a torus, donut shape, bagel, ring. So there you go. If you can imagine trying to make this with just the extrude feature and the fillets, you could do it, but it wouldn't be nearly as easy. So, all right, I've demonstrated two things you can do with revolve, but you might be thinking to yourself, like, that's not that practical. Like, I'm never going to need to model a ball bearing or a donut. And that's true. And the other thing you might have noticed is that everything I can do with revolve, you can pretty much do with an extrude and fillets, right? So why should I care? And so that's where I'll kind of introduce like when you should use this. I always like to bring up this example. Let's say you're making a shape kind of like this tier cake. So you have a cylinder on a cylinder on a cylinder. And so as of last week, the approach perhaps you would have taken is kind of like what I showed at the beginning of this class, actually. Make a circle, extrude it, draw another circle, extrude it, and so on. And so if I wanted 3 tiers on my cake, I'd have to do that 3 times. But for the same reasons that I showed at the beginning of this class, that's kind of impractical. If you need to change something, it's going to be going through all your different sketches. I already created like 3 sketches there just to create that one body. And so what I'd like you to consider is that whenever you have to model something like that, think about rotational symmetry, right? That kind of shape is rotationally symmetric in that if you cut it down the middle, no matter what angle you cut it at, you get pretty much the same cross section. So if I made a sketch something like that, I could revolve it, pick a vertical axis, and just like that, in one sketch and one feature, I created this shape that took me like 3 sketches and 3 features using extrusions. And even though both of them create like the completely accurate model, you can imagine this one's a lot easier to work with. I can change all the dimensions in a single sketch. I can reference them with each other, things like that. And shapes like this are actually surprisingly common, especially if you're working with like engines or automotive applications. Anything that spins essentially is going to be pretty circular. So there's going to be a lot of symmetry that you can exploit. As some examples, this is one that I really found interesting. So on a car, you have your rims, right? That the tire goes on. You have something like this, and then the tire goes on the outside. And so let's say that you're the engineer who is making the model for this. How are you going to make this complicated like sheet metal cross-sectional, or the sheet metal shape? Well, it turns out maybe you know what the cross-section of the rim looks like. Maybe you cut one open, and all you have to do is model this shape, and then you can revolve it, and then you have a perfectly accurate rim without having to deal with all these complicated surfaces that aren't like flat, maybe all these weird fillets and bumps. All of those can be encompassed in a single sketch. And that's kind of the power there. So the past couple of weeks, I kind of bring you a challenge for those of you who are fast and perhaps go through the demonstrations faster than I go through them. So for those of you, I challenge you to create a lamp, specifically the kind with like the lampshade. So you can see a shape like this is actually pretty rotationally symmetric, right? Like if you spin it around, there's no like one angle that makes it different. Like as you spin it around, it looks pretty much exactly the same. So just pick any lamp you like, try to make this thing in just a sketch. Don't worry about like the inside of it or what it has to look like. Just try making a shape like this using revolve. And that's the challenge for those of you who ever find yourself in want of something to do. So that was a revolve. If you have any questions about that, please ask it now. And if there are none, we'll move on to the next topic. That's very fast. Already on the next thing. So I might have mentioned this before as well. Another thing you want to learn is how to create a CAD model where there's multiple different parts that fit together, right? So maybe not at the beginning, but as you progress in your CAD level, it's going to become more rare when you're just modeling a single part, a single solid object. You're often going to be doing things that are multiple objects that kind of go together, whether that's like, I guess here you see some examples of previous class projects. You have this little kinematic device, this handle that spins around. You have this sprocket with pedals on it, where you can imagine the motion of that pedal thing. And so that's all done in the assembly. And to start us off on that assembly, I'm just gonna have us quickly model a part, probably one that you're familiar with. It's like a toy Lego brick. And using that, we're going to start working with our first assembly where we put in multiple bricks and just try to assemble something like you would in real life. For those of you who perhaps don't get what I'm talking about, although I'm sure you do, yeah, something like that, right? So that's what we'll model in class today, and then we'll get to the assembly and we'll see where we stand at that point. So I guess I'll leave that up. As usual, I'll ask you, what shapes do you see here? How would you go about modeling this? And don't worry too much about the inside here. that might be a bit more complicated, but just looking at something like this from the exterior view, what do you see? What tools do you know that can do this?
A big extruded rectangle
All right. So
and
that's
a
this,
bunch of cylinders on top.
yeah. And that's pretty much it. I don't see too much else on here except the word, but that's a trademark, so we'll not go there. So yeah, a big rectangle with a bunch of cylinders on it. So hopefully you all know how to do that. If you feel bold, try doing it yourself. Try doing it faster than I can. But we'll start off. We have our rectangle. Now let's say we'll make a really big one. We'll dimension it with our whole dimension tool, 4 inches and 2 inches. So extremely large, it's like this big, but this isn't real. So that's kind of the body of it, and we're gonna have those cylinders on top. So I'll just draw one of those cylinders for now. Give it some dimensions, locate it properly in space. So I know what's not dimensioned about it right now is its location. And I just added the dimensions, so everything's black. I might have gone through that a bit fast, but it's nothing you haven't seen before. If you had any problems with this part, ask a question. And as we go on, I'm going to introduce something, again, new tool. It's actually kind of connected to a tool that we have used before, which is our sketch patterns. So if I were just to keep going from here, you would tell that I would have to make 8 of these, right? Or 6 of these, however many fit inside, right? And I don't really want to sit here drawing all of those circles and doing all of these dimensions for every single one of those circles. The tool that's available to me is the linear pattern. So before we use the circular pattern for the sprocket teeth, so instead of a circle, it's going to be kind of linear. Again, for the sketch patterns, you can't really see, like a window doesn't come up like it does for the feature patterns. It just kind of highlights the tool. So you know it's active because it's highlighted, it's the linear pattern. And while it's highlighted, while it's active, I click on this circle and whole UI comes up. And it might look a bit familiar. It's sort of similar to the sketch pattern for the circular pattern, where I have these numbers with an X after them. I have these arrows and these boxes that I can drag around just to show you what happens. Like I can drag this around, I can drag this around. But what it's essentially doing is allowing me to easily create a grid, a linear pattern, so to speak, of this shape that I selected. So I'll show that one more time. I click the tool, I click the thing that I want to pattern, which is that circle. And now, just like I did with the circular pattern, I'll kind of put in some actual numbers that I want. Maybe something like that, looks pretty good. All I did was change the numbers with the X, which is the number of instances. And I'm pretty happy with that. So I'll just click in the background. You'll see your cursor has that green check mark. And in this case, it just happened to be all fully defined. So I'm good to go. Is everyone good with that? No issues with the pattern? I see a wait. So I shall. I can show it again too. hopefully you're able to find the pattern. It's in front of mirror before this DXF thing. Yeah, I see other people are asking too. Yeah, so if you missed the part before I started this whole thing, what I'm trying to do is make these 8 circles along this entire block. So I don't want to sit here and draw 8 circles one after the other like this. So I'm going to use the linear pattern. It might be in a drop-down menu. It's the same place where you got the circular pattern for the sprocket last week. Maybe it was 2 weeks ago. I think it was last week. So you want this to come active, and then you click on the thing that you want to pattern, which is the circle.
Wait, how did you make the 0.5s and the 1, like the dimensions?
Good question. Are you talking about those?
Yeah.
Yeah, so like I've said a few times, this dimension tool is smart, right? It can do multiple different types of dimensions all in the same tool. So for instance, you can see for like the height and width, these are length dimensions. When I click on a circle, it gives me a diameter dimension. And the way that I can do a distance dimension, which is like the distance between 2 points, for instance, perhaps the distance between 2 parallel lines, I can click on a point. I'm not sure if that registered. Yeah, I did. Okay. So I click on the point and I click on another point. So all I've done right now, 2 clicks. I clicked on the center of the circle. I clicked on the origin. And this arrow comes up. Now, as I move my mouse, the smart dimensioning tool tries to guess what kind of dimension I'm making. Do I want a horizontal dimension? Do I want a vertical dimension? Do I want a minimum distance dimension? You can see the direction of the arrow changes as I move my mouse around. Hopefully you see that as well. Hopefully that makes sense. Kind of the arrows kind of indicate what direction it's measuring. So there's this angled direction, there's this horizontal one, there's this vertical one. All I need to do is move my mouse kind of down here to the left until the arrows kind of are vertical. And then if I click again, I can put in a number, 0.5. One more time, I have my dimension tool active. I take the point, I take the origin, I move my mouse so that the arrows this time are horizontal because I want the horizontal dimension of this distance. So not the vertical one, not this angled one, but this horizontal one. I click again and I type in a number. Let me know if that was good or if it was not. Okay, great. So having that, hopefully you have a completely black sketch now, fully dimensioned, everything's defined. What we're gonna do is use our linear pattern. So again, that's same place as the circular pattern. You click it once, it gets highlighted, now it's active. And with it active, I'm going to click on this circle. I clicked it, and this comes up. And it's a very similar interface to the circle pattern, where I have these things that I can drag around. I have these numbers with the X's in front of them. And so all I need to do right now, I'm happy with the direction. I just want a horizontal one and a vertical one. So I'll change the number by double clicking on that. Type in a number. Again, for the vertical one, I double click on the number and I type in another number. Let me know if that works for you. Great. And once you have that, you can just left click in the background. You'll see the green check mark on your little mouse icon. And in my case, it just turns out to be all black. Hopefully that happens for you as well. But if not, it's probably a similar case where the position might not be defined. So I might have to drag it around and do a relation. I kind of wish I could demonstrate it, but it just worked out. In fact, I can demonstrate it just by dragging it before I accept it, but let me know if you still don't have it. And I'll take the lack of response as everyone's good. Wonderful. So I'm done with my sketch now. I'll accept it, and here I go. So the first part of my brick is the body of it, the rectangular part. So I'll start with that. And as was observed by one of you guys, I can extrude that. So as I've done before, I select my regions. And for the body, I do want to have everything be filled. So I will click on each of these regions just to fill them up. And we've seen that before. I know last week when I was demonstrating my sprocket, the teeth didn't automatically come up because the regions were not connected. So I had the option to click every single tooth. That's kind of what I'm doing here. I'm just clicking on these circles. They're highlighted in orange. You can see it even bigger. Yeah. So hopefully this was all good. What I'm going to do now is I'm going to click this button. It's called opposite direction. And all that does is it flips the block around. So instead of extruding up into the positive Z axis, which you see in this navigation cube, instead of going up, it goes down. You see the arrow change direction too. That's going in the negative Z direction. Kind of drag it around. You can see it's below the top plane now. Right now it's above the top plane. I click opposite direction, it's below. And the only reason I did that is because I want my brick to be right side up when I'm done with all this. So nothing too complex. You have holes on both faces. I'm not sure what you mean by both faces. What I imagine is that you might be clicking these regions. So if you do have holes in this selection box where it says faces and sketch regions to extrude, you can just click additional regions, and all of those circles that you had in your sketch should be acceptable regions. Does that work? Okay, great. Yeah, so I'll extrude this and I'll just make sure that the direction is down. And I can also just do that by dragging my arrow around. As for the depth, actually 1 inch looked pretty good. Yeah, I think I like that. So that's what I'll do, and I'll accept. So now we're pretty much there, right? We have a brick, which is the essence of it. I am missing the cylinders on top. So to add that, I want to extrude all those circles that I had, but you can see they're missing now. They're gone. I think we went over this before, but everything in the feature tree has a little eyeball, and you can click on the eye or the crossed out eye to toggle its visibility. So the sketch was hidden, now it's not because I clicked the eye. So I bring my sketch back up and I'll do another extrude. And this time when I'm selecting my regions, I will not click on the rectangle. I will just click on the individual circles. one at a time, like so. For the height, that's a bit tall. Maybe a 1/4 inch is more my style. Something like that. So are we all good on that? Is anyone not good on that? Okay. So I'll accept it. And here we go. I'll just hide my sketch again. Ooh, I see a message. How do you change the color of the shape? It can mean like the part appearance. You can right click on part 1 in your part menu here below your feature tree. You right click, the 4th option is edit appearance, and you can just pick a color. That's my best guess as to what you mean by that. If that's not what you meant. Okay, great. And I'll do one last thing, introduce one more tool to you guys, and that is the shell tool. So in kind of this second group of 3D tools, the 5th one is called shell. Looks like a kind of square U block with a little cavity in it. Shell. So find that, click that, brings up another window for the shell tool. And what the shell essentially does is it takes a solid geometry, it asks you for a face, and then starting at that face, basically digs out all the material in that connected region until you're left with a thin shell that has a certain dimension. And so that's what I want right now. So I open up my shell tool. Again, that's this one right here. And for my face selection, I'm going to pick the bottom face. And you can see what happens. It's kind of like a hollowed out shape now. It went through the entire solid region and it just dug out material until everything was, in this case, 0.1 inches thick. What I can do, I can make it a bit thicker if I want. Maybe I want an 1/8 inch. Maybe even thicker, like 1/4 inch. I think in terms of realism, that might be the correct one, just because these stack together by having these cylinders touch the inside here. So not too complicated, just get your shell tool, click on this bottom face, and set your dimension to whatever you want. And at this point, you're pretty much done. That's all there is to it. If you had any trouble with that, say something. Because if not, I'm going to hide all of my reference geometry just so it looks clean. And I'll call this finished. And we're going to go into assembly. If you want, you can change the color. I don't know. All right, no one says anything, so we will step forward into assembly. So the bottom of your document, by default, you probably have an assembly already. Maybe you do not. The way you create one is by clicking the plus sign and this option, create assembly, brings this up. So find your way into this workspace. You can see the top bar has all kinds of new stuff. Not to worry, we'll start out just in a similar way as you start a part with a sketch, you start an assembly with a part. So the first tool you have is called insert. It's up here and you can click it. And you have some options. We won't worry about these for now. This is if you want to work with parts that are in another document or from somewhere else. right now we just want to work with that part that's in the same part studio, or in the same document rather, in a part studio. So this part studio 1 here, maybe I'll rename it for clarity. Brick. I insert from the brick part studio, part 1. So I click part 1, and let me show that one more time. Insert part 1, and I move my mouse out into the workspace. The part follows my cursor kind of, and I can just click once to accept the position, and that's set. If I want another one, which I do, I click it again. Another one comes up, it follows my cursor. I just need to click again. Maybe a third one, why not? And maybe 3 is enough for me for now. So with that, I click the check mark up here to accept what I've done. And now I've inserted these 3 parts. You can see they're all named part 1. Whoops. If you click on it there, apparently it opens it. But here I go. Is everyone able to do this? Okay. So we have this. I see a message. Yeah, okay. So we have this now. I want you to just try playing around with it. You can see all of these can be freely moved around. Your reference point in your assembly here is the origin. So just like you had an origin in your part, we also have an origin in our assembly. This is your reference frame for where everything is. The center of your assembly is this point. So relative to that, you can see the bricks can just be moved freely. And so when you make an assembly, generally you want everything to be, not everything, but you want some logical part of your assembly to be fixed in space in your assembly. And that's because perhaps you're gonna make another assembly that uses this assembly, and you don't want your assembly, your subassembly, when you import it, just be some weird place in space. You want it to be in the subassembly's origin. And so essentially what that means for us is that we want one of these Lego bricks to be fixed. We don't want it to be movable freely like this. And so one way we can do that is doing something called fixing the part. Let's say I choose this one. What I can do is right click on it. And when I do that, one of my options is called fix, kind of the bottom of this first group of things in my right click window. So I can fix that. And once I fixed it, you can see next to that part, there is this ground symbol, and that means it's fixed. So I can no longer move it around. You can see my cursor has this cross through. And you can even see like the ground symbol shows up when I try to move it. Right here, that's the ground symbol, as opposed to these, which can still move freely. So that's one way. Now I have this kind of fixed foundation upon which I can start making other relationships. But let's say that I actually want this brick to be fixed right on this origin. So right now it's not, you can see it's not really on it. So to move it into place, I'll need to unfix it. I can do that just by right clicking the part and clicking unfix. Or I can right click here on the part and just click unfix. Simple as that. But this is where I'm going to introduce the first mate in Onshape. And so, like I said, the purpose of the assembly is to have multiple parts that have some known relationship with each other in terms of how they can move with respect to each other. And so the first most straightforward mate is the fasten mate. That's the very first one in this whole bar. And as the name implies, what it does is it fastens things together. It secures them, it glues them in place, fastens them. if I click fasten, it brings up a window. And it asks me for mate connectors. And so this is where it will get kind of tricky, perhaps, if you're not used to this kind of mating system. I know every CAD software does this a bit differently. I think Onshape is kind of similar to the way Fusion does this. It's rather different from the way SolidWorks does it, which is what I'm more used to, but we have mate connectors. So what are mate connectors? It's essentially any location, whether on a part or whether on a reference, that allows you to tell Onshape where to connect things together. So my objective right now is to get one of these bricks fastened to the origin so that effectively it's fixed, but it's also right on the origin. Maybe one of the corners can be right on the origin. So my first mate connector logically should be the origin, because that's one of the things that are involved in this whole operation. So if I hover my mouse over this origin point, you can see this 3-axis thing comes up. And as I move my mouse around, you can see my mate connector, which is that little circle with a like little Pac-Man shape. You can see that changes orientation as I move my mouse around. And so right now in this orientation, it's facing in the Z direction. When it's like this, it's facing in the X direction. When it's like this, it's facing in the Y direction. So I want, let's say, Z direction. So I hover my mouse, so the little disk is facing up, and I click. See, there's a little faint outline of it. And my first mate connector is selected. For my second one, I'm going to select a mate connector on my brick. That's the other part of this operation. And I want the corner. So I'm going to bring my mouse over onto this corner. And just like I could, you're going to have to kind of play with this to get a feel for how it works. But once you get used to it, you'll be able to kind of like naturally choose one. If I just bring my mouse cursor up, the mate connector, you can see right at my cursor, it's another disk that points straight up. And so what you can imagine is going to happen is once I click this, the two mate connectors, the one on the origin and the one on my cursor, those two are going to kind of occupy the same space. They're going to become one. Just to show you how that works, I clicked it, they go together. Sometimes it might not happen instantly. In that case, you would press solve, but right now it's already solved. And if you're happy with this, you can kind of I guess there's nothing to animate. I know Fusion does animate like fastens, but in any case, this is what I want. So I can press green check mark. I will show that again, just because when you're first getting into it, it's kind of crazy with all the different boxes going up. So for the origin, that's my first mate connector. I hover over the origin, and then I have 3 choices of what direction to go to. I'll choose Z. And for my second one, I want this corner. And if I just hover like slightly around this point, it'll be the one I want. Maybe I want, for instance, this one. So the way I kind of get there is to hover over this face and then drag my mouse to it. Maybe I want the one on this face. But in my case, I just want this one. So it's a bit finicky. Hopefully you're able to do it. Let me know if you have a problem with that. But that is your first mate. And so what happens now is the brick is fastened. It's glued in place to the origin such that that corner that I picked is fastened to the origin. So it can't spin, it can't move. Unlike these bricks, it is now kind of my reference point. All right, are there any issues with that? All right, no reply, which is hopefully a good thing. So what we're going to do now is we have these 3 that I brought in here. We're going to use them. And so I'll fasten the brick to another brick. In this case, you'll see that I have some options. There is more than one way I can do this. I will show a couple. Just like before, it is a fasten mate. It's the same thing essentially that we're doing. So let's say that I'm going to pick the corner again as my mate connectors. So my objective right now is to stack these bricks just right on top of each other, just like that. So what I do, I pull up the fasten tool and I want my mate connectors. So I'm going to use the corner. So it's a bit hard to verbally explain, but as you get a feel for it, you can kind of understand how to move your mouse so that you get the right connector you want. I kind of want a connector on this corner that's pointing up, but as I'll show you later, that it's not the only way that this can go. So let's say I pick that one. So I just clicked once, that's all I did. And now I'm not holding anything, I'm not clicking anything. I move over to this other brick and I click the corresponding corner. So that's this one. I'm not quite getting the one I want, but I'll just fiddle with it until I do. Yeah, just like that. So that ended up working. Maybe something like that. And so once I do that, they snap into place. If they don't, you can try solving. But this is what I want, so I would click the green check mark. Sometimes it'll happen that the orientation of these things won't be what you expect. Maybe like it'll join the corners like this, or maybe even upside down, right? So that can happen, but as you just saw me do, you have these two control options. One of them is to flip your primary axis so that just flips the mate connector upside down. You can see what it's doing right now. It's flipping it about the mate connector. The second option is the secondary axis. So now it's turning the mate connector. So even if you don't perhaps select the exact correct orientation and direction of your mate connector, a lot of the time you can just use these two tools to fix it. So I hope that worked. I'll pause a moment for questions. And seeing none, I will do the next one. And I will try something a bit different this time. Maybe I won't have the bricks just be on top of each other perfectly. I'll have one be offset a bit, so it's hanging off the edge. So I already have my fasten window up, just like that. And so this time I want this corner of the brick essentially to be kind of at the halfway point here. So the way I'll do that, as before, I can select my mate connector on this brick. And then I just click that one once. I come over to this brick where I want to put it. And I select this point, which is kind of halfway there. And when I click on it, it snaps into place. This is what I want. So I'll just the green check mark. Now I have the brick kind of halfway offset. And here you can kind of actually see everything is together. No interference. We're all good. All right, so that was kind of your introduction into assembly. Nothing too crazy so far. We're just fastening things. So it's equivalent to like gluing them together, maybe attaching them some other way. And you can see there's a whole lot of other mates. What we're probably going to go into next week is more with assemblies. So one thing I'm thinking, we might try to do something similar to this one using the sprockets we made previously. Maybe not this exact thing, just a simpler version with just a stand and a handle. And we'll use some of these mates that allow you to spin things around or do other things. So that's the demo. I guess I will show, I did say I'd show that you can do this multiple ways. So for the fasten mate, for example, let's say I'm going to do the same thing that they did before. Any 2 points that'll end up in the same place, for instance, this point and this point, can also be used. So to achieve that same goal, like there's no set pair of make connectors you have to use. Just as long as it makes sense, it'll probably work. All right. So we're nearing the end. I haven't heard any questions yet. If I missed one, let me know. And if not, if anyone did the lamp, I would be interested in opening the floor to that. Did anyone attempt it? Maybe. I know it was a perhaps busier class with more new content. You didn't miss anything. It's just like each week for the past 2 weeks, I guess, I just say if anyone's bored, they can attempt a challenge. So for this week, towards the beginning, after the revolve, I said, try a lamp. It seems like today I did a pretty good job of keeping you busy. So I'll take that. Seems good to me. If you do want to try, just as a reminder, it's kind of like one of those lamps with a lampshade on them, something like that, where it's rotationally symmetric. And you could just make this with a revolve feature. So if you want to try it over the week, keep your on-shape practice sharp, you're welcome to. Otherwise, when we come back, we'll just keep working on assemblies. And after that, probably try to do a bigger project, maybe something like this kinematic machine to wrap up the class. And I'll talk about 3D printing stuff, maybe towards the end. All right, so if there are no other questions, that's all you've got. Another good class, so I'll see you next week, same time, 7:15, Thursday. Yeah, that's all.
Bye.
Goodbye.